Hello, and in this video I'm going to see how to create a symbol in Kicad and understand all the steps that Kicad requires to create a symbol of a component which is not in the Kicad library. And the final result is exactly the one that we see here. This one is a symbol for the 1602 keypad, which is this one. And so I'm going to create the same, but a new one, and see how to do it, the steps to follow. The final result is going to be this. Then also see the relative footprint, how we can create the footprint. And in order to achieve the final result, which is this one, which is actually the circuit board, and this one is very simple, just to show that the things are working. And and see the 3D final result, which is this one. So this is our goal, and so let's get started. So the first thing to do is to create a project in Kicad, and we go up here and do is in the file menu and do a project, and we actually create a new project. We can choose now is say file name is a new project, new test. After we create a project, we are going to create the symbol itself. Is by clicking this icon here, we are ready now to create a symbol. Before creating a symbol, we have to understand what Kicad wants to successfully save a symbol in the new symbol that we are going to create. So if we look here in the file menu, we have some options that are available. And we have to concentrate our attention here, because one thing that is important is that each symbol we are going to create wants a library as a folder for itself. So for example, let's see now creating a new symbol. So creating a new symbol, as you can see, Kicad wants a library here. Wants a library where this symbol is going to be saved. In this case, this one is already selected. It's a shield. It's a library that I created previously. And so if I click OK, now we are Kicad gives all the options to start creating this new symbol with the symbol name, the reference, etc. So, but if we don't have a library where the symbol is going to be saved or stored, actually, we have to create a new library. We have two options to do that. One is to create a new library ex novo. So this one is actually a library that we can use and give a name to this library and save it. If we go ahead, for example, let's say this new library, leave the name now, is not, this one is an arbitrary name and you can give any name you want. But if we save, save, you see that Kicad wants us to specify what library is going to be created. Is a global library or is project. Global library means that this library can be shared in the future projects. So you can use this library also in the next project you are going to create, or is if this library is specific to this project. Actually, the one can see that it's maybe specific to this project doesn't make too much sense, but it's indeed is if you have a specific requirements for the project that you working on, and you want, for example, to modify a symbol for that specific requirements. So probably this option here is more adequate for this purposes. Or otherwise, global probably is the one that people want to use more. It depends of specific needs. I'm not going to create now this library, but if you click OK, here is the library is going to be created, so I don't give cancel now. And so the next step is actually to see another options. Here is add library. This actually, if you have a library already created in the past, so for example, see this one, no, this one is this one. As you can see here, there is shield library, which is the one that I used before. I'm already using here in this project. So you can specify a library that you already created in the past. Not going to select now because already there. Next is this import symbol. If you already have a symbol on your disk, again, as you can see here, that Kicad wants the library to be saved in, and this one is shield, and then gives the opportunity to import the symbol and load in the library you selected. Okay, this one was the details that were that I felt to be specified before starting creating a new symbol, because of that one was a thing that is very basic steps and are not very well explained probably around. So let's go ahead now with the creation of a new symbol. I create here a new symbol, and we choose this shield, which is my library. Okay. Now give this symbol a name. Now this is, for example, let's call it shield. We give the reference, we give sh, it's okay. And for these options, I leave unchecked. I'm not very sure what is this the Morgan body style, the Morgan tail. I think that it's actually for the many components may have different symbols, and so you can choose the right symbol for their project. But I'm not sure about that. I never investigated well what is the Morgan check option here to select it, but I think that is that one. So now we go ahead to creating the symbol. Oh, now we have the see the reference, the name of the symbol, which is overlapping each other. So we had to move. One is just select one M and select the shield, and then we move it somewhere else. Same thing for the other one. For the reference, move it, and we go back. Okay, let's see here. I think it's okay. Okay, now we have this very basic things of creating a new symbol. We had to create the new symbol. Start with this tool here, and it's a rectangle, and with a rectangle I'm going to create a rectangle here. The size doesn't matter actually. It's as far as you can fit all the pins that we are going to create now, very soon. The size this time, oddly enough, doesn't really matter. And so we go ahead and see how to create now the pins. To do that, we need the schematic of the component we are going to create. So let's see now this schematic. To create the layout of the pinout of the symbol, I using this image here, where this is reported all the pin input output signals. So we go back to Kicad and start pinning the symbol here, and with the first one. The first one is this one is reset RST. So we do that here. We give a name RST. So for the pin number, actually we have to pay attention, because pin number here must match the pin number with on the footprint. So in other words, what the pin number we specify here must have the same reference to the footprint we are going to create later. I'm going to see later what is the pin number here. For the time being, I prefer to leave it blank without giving a number here, and fill it in when is when we have to the footprint ready. So let's continue with this pin, and this one is reset, so is an input line, and we have to give also the orientation. Give the orientation is this up, and we are ready to set the pin here. Then we go to the next one. The next one is output 3.3 volts. So we go back here and create another one. I think I'm going to change up here is view, grid setting, and give a little bit more. Yeah. Okay, so the next one is 3.3 3 volts. Is an output power output. up also, this one, and okay, let's put it here. Or let's do the next one. The next one is 5 volts out. So go back to 5 volts and create another one. Here is 5 volt. Also power output up, okay. Okay, so maybe the rectangle must be a little bit taller, because otherwise we don't have the reference name for the other side. So I'm going to now to modify the rectangle here and continue to fill it in all the pin, and I will come back when I finished everything and continue then with all the rest. So I finished to create the symbol. Actually, what I've done is I used my previous one, since I making here the same symbol that I created some day ago. I just copied. It's a copy and paste here. And if you need to copy and modify some other symbol in already in the library, and you want to modify it for your purposes, this is possible to do it. So take a symbol elsewhere here in the libraries and copy it and paste it on your symbol design, and then you can modify as you want. This one is possible to do it, so save time in that way. One thing also they have done is, since here is this one, the library is called shields, and the symbol that I created before was named shield. In order to avoid confusion, I create another one, which is actually the same of this one, is but with another name. So I remove that one, and things is a little bit clearer to understand. So here is basically this one is completed. It's now what we have to do is to associate a footprint, and to do that we have to go back to Kicad main program. Okay, here is this icon, is the footprint editor, and we click on it, and this is the editor for the footprint, and now we are going to create our footprint for the shield and relative symbol we just created. Okay, so if we do this, look at here. This one is the library that I created, and okay, basically you can create now a footprint in two different ways. One is using the wizard. Here you have a bunch of footprints already created, which are quite standard and are possible to modify. Let's take one of them. Is for example, let's take this one, and here you can change the number of pins, the pitch, the width, etc. This one is a wizard, and if you have actually a footprint that is of your components that matches and reflects this this pattern, so you can use this one. just to understand how they are, where are this located, or this list here, where to find this list is actually in this path, is program files, Kicad, share, Kicad, scripting and plugins. If you notice now, also, I'll try to see if I can, there is a certain relationship from the list we got here and the file name of this files here. This actually, the wizard is actually a Python script which give the basic information to create the footprint, and then modify it with using the parameter to as shown in this list, in this table here. So we modify this parameter, and with Python script we reflect our modification to the footprint itself. This is not the case for us, because we have a different type of footprint, and we had to create manually. So I close this one, but this one is a good way in case you have, for example, a pattern or a footprint like this. This one is actually a good way to save time to create all this footprint manually. Yeah, all these pins and everything. We are not so lucky, so we have to create manually, and there is this other option here, which is a new footprint, and you give a name of the footprint. Now I don't give now the name of the footprint because I already done one, and just not to mess around with my library, I wish to take a footprint that already created, which is actually is empty, but is possible to modify. So this one is you give a name and you create a footprint. Okay, let's try. Okay, let's do this testing footprint. Okay. Yeah, this one is ready. Now you see that there is a reference and the name of our footprint. Where is this testing footprint? Must be around here. Tested foot. No, it's well, actually it's nowhere because we didn't save it. So this one we have to save it, and then we can specify where to create it, actually, where to save it. You see now there is the libraries where it's possible to associate this footprint here, but we don't do that now. So we discard this one, and we use this Pincapallino, which is discard the changes, yes, which is the name Pincapallino is anyone in Italian. It means anyone. So when you want to see any person, you see Pinco Pallino, which is a general person. So we use here for the footprint, and we see how to create now the footprint itself. So we have to create it manually, and to do that, we go to this. We have to add paths. Okay, so this one is we add one. You see now there is now the number. do you remember the number that we were using on the of the symbol, that we had to match some numbers? This one is the matching is with this footprint here, with this pads. Okay, now it's stop now. We had to match the same number we gave to the symbol with the number in this of the pads, of the relative pads. This is quite important. It's very important, because otherwise there is big problem in when you are creating the PCB and the circuit itself. So be careful. The number of these pads must match the relative number of the symbol you created before. I'm not going on now, because I show you a way that to save time also, because we can take something that is already made and modify it, and save time to create by hand all the pins one by one, and so all the pads. So I use just these 4 pins just to show what the pads, the setting of the pads, and how to setting up and stuff like that. Okay, so let's create this double click here. Okay, now this one is relative to the pad 1, and as you can see here, there is the possibility to give some characteristic of this pad. Okay, let's to see if I can move in this way. Okay, so the first one is a through hole, or SMD, or connector, or mechanical, or anything that it can be on a circuit for the symbol we created before, so must be compliant. In this case, for us, it's a through hole, and the through hole can be circular, oval. Look there, look here, look this one, all these parameters here. If I do oval, you see that there is an offset. I can specify the length, the size of. If I give circular, there is no just X size. There is no Y size, of course. If I specify oval, is Y size, which if we modify, you see what happened is I don't know, we put 2 or 0.5 or 0.8 or 0.9, etc. Okay, so it's possible to create oval in this way, and the Kicad reflects automatically the parameter, enables actually the parameter according to the shape you choose. So this one is rectangular. You see now is if we don't give 1.24, is the rectangle is a square, so it's trapezoidal. So in this trapezoidal is vertical, and the delta. So if we give 0.5 delta, you see that is assume this shape, or horizontally. So there is actually a possibility, I think all the possibility for the paths to create the correct paths for our component. Okay, so let's go back to the circular one, and there is also another important thing to do. Is this one is all copper layers, to select this one, or we can choose the front copper and the back one. In our case is all copper layers, so we leave this on, and then we click OK. The same thing we can do for all the others. I'm not going on now because we are going to see how to copy something that has been already made and adapt it to our purposes. And now we see how. So here is our footprint. Now I deleted the paths that are created before. And now we see how to actually use something that is already made for our purposes. This one is Arduino Shield, so it's supposed to be more or less the same footprint of an Arduino board. In Kicad we have the Arduino board, we have Arduino Uno board footprint, and we find that in modules. In module, here it is, and there is this Arduino Uno R2. So we can use actually this footprint for our needs, and we can do that by exporting. We go to File here, and then we go to Export Footprint, and we can now export this this footprint to the directory we like. And I already made this one. It's Arduino Uno. It's the same actually, so I don't. Okay, I can give save this replacing, but it's actually the same file. So yes, and so we can now import the same footprint here in our project here, and we can do that. Always on File is import for Kicad file, and we have this one. Here we got the our footprint ready-made. We had to modify it, of course. Now we have to modify for our needs, and it's possible to do it by deleting this one. Remove all these parts. We don't need that. We don't need also this one. I removed the border of the other footprint, so we can modify now for our purposes this one. The first one is I want to change the name, and this one is I call it Pinco Pallino. You like it or not, this one is now is the name of this footprint. Then we can do also one thing is basically I would like to swap upside down these pins. I like this one to have on the top and this one to have on the bottom. So I take this one, as a right click and use flip. So up and down. Nice. Okay. Okay. So I flipped that one also. This one is the reference we have two references. This one is for one of them we can remove. Yes. So this one is when you flip this one. When I flipped the footprint, actually there was flipped also the name and the reference. It was in that way, so it's just enough to go back and say flip, and so you bring back readable name and reference. So now we have to look now this the relationship between, also this one is very important, check and double check this, also triple check this relationship between the pad numbers and number in the symbol, because this is very important. It's basic to successfully finish your work. Otherwise might have some problem with non pin non matching with reality. Okay, so now we have to create one quite important thing, which is the called, which is called, that one is this name here is courtyard. What is a courtyard? Courtyard is actually is the clearance. So when we put this module or this shield in a circuit, of course he got his own shape and size. So we had to give a clearance and to specify a clearance, so that when we place on the PCB, Kicad can actually perform some automatic check to see if there are components that are overlapping. In that case, when we give the command to check if the PCB is correctly layered and place all the components as they should be, this Kicad can check if there are some components that are too close and or if even are overlapping, and give us a message, so we can actually modify and amend the problem. So we had to specify the clearance. Now, since I'm duplicating now what I already created, I can take okay, now this no, before doing that is now we can save it, this one, because it's some job that we have done and we can save it. And guess what, now we had to specify a library also, because also the footprint wants a library to as a folder or as a container for itself. So we had to specify a library, and as you can see here, there is a new library, add library, a little bit like we did with symbol. Now we have to do with footprint 2. To do that, we can have add library if we have a library in our disk, in our computer. So we can select a library from somewhere in the directories, in our directories. We can create a brand new library or choose another existing one, and that's what we are actually doing, because this one we are to actually save it to this library here, this 1602 LCD keypad. Okay, so this one is a save. As you can see, save footprint. You see that once library, that one we want there, and we change the name, of course. So this footprint we call Pinco Palino. Okay, see. Okay, now we have actually the one. So, well, this one, if we can remove it. Yeah, we gave another name. So remove this one. Delete. We use this. Okay. So, as I said before, this one is actually a replica of what we done this here. So I can use this sides and this border here to recreate the same on our new footprint. Here there is a caliper, there is a measure tool to measure the distance. So I can choose this one, just here, and I'm gonna around and see that the clearance I gave on the other my previous footprint is roughly 90 millimeter. So we had to specify this one to give 90 millimeter, and the 8, okay, 8 is this one, 90 millimeter, and the 8 is around 58 millimeter, more or less 58 59. Okay, so now we know the 80 by 59, right? I write down now, so 80 is 80 by 59, more or less. Okay, so we had to create this clearance with this with this dimension here. Okay, go back here, and now we create the this clearance box. One thing that is the missing is that when we use the measure here, measure tool, we don't have any possibility to, for example, if I do that one and I leave, okay, now I know that this one is 58 millimeter long, but if I choose something to create something that is with these sides, look what happened. Everything goes away. So we don't have any reference now to create our shapes and so precisely, actually. So there is one I found a way, which is I think that's the only one. I don't know if there is some other, but this one is apparently is working. This one is actually the 0 coordinates points. As you can see here, there are these coordinates here, right, reflects where I'm moving with the mouse. So if I go there to 0 0, and now I zoom in a bit, yeah, I can actually make the starting point here and create a box with that dimension we know and we measured before. One way is this one is maybe to create this one is a graphic polygon but I prefer to use this one. Even this one is quite easy to use because it's actually give a rectangle. You can create a rectangle. With this one, you create the rectangle. This one is this drawing a rectangle. This one is must create border by border, yeah, side by side, and create the rectangle. I think this one is also possible, and you see now you can create a rectangle, yeah, in that way, yeah. In that way, but is filled in, so that is the problem. I never found anything to avoid this fill-in feature, so I actually use the way that I'm used to, and this one. So the size was 80. We start from here. 80. I can use a little bit larger, so it's not so less granularity. You see now it's 0 0. Okay, use now 80. Go down, 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 down. 80. 65, 67, 80, 80, 70, 2, 29, 80. Okay. Then we go up. You can use the control key to go straight, you see? Or otherwise, if you don't use the control key, is this. If you use control key, you get straight. And we go up for 59. Go up, 59, 7, 8, 9, okay. Okay, even less, it was a 58, okay. I think it's okay. I'll give it okay. Then click on it, and then go back to our also 0 0 here, okay, 0, here we go, and then go back, and then look, when you reach the other top side of the line we draw before, there is, you see, there is a circle. The Kicad create a circle around. That means that the two points are matching, and this is joined. So use this one, and then here we are. Okay, now we can move it. One thing, you see now there is the cross. You can change how the cross is shown by this full window crosshair. You see now it's like a real cross. It's a small cross. I think in this case it's better to use this full window crosshair. Yeah. Okay, now we choose this one. Oh dear, now it's a little bit tricky because we have to remove. Okay, now we can remove the parts we don't want to be selected by holding down the shift key and then select the elements we want to exclude from our selection. Okay, now we put in that way. This reference also we move a little bit. In case you do the same as I did, which is I created this clearance borders not in the courtyard, but in F silk, and I have to actually bring back to the courtyard here. So it's to do that is clicking on this one, double clicking actually, and go here and go to the front courtyard. Yeah, that one. Same thing for the other one. This one is actually the courtyard. Now we have to create, as we can see here. Oh yes, we save it. We have to create this the border where actually the real sides of the shield. We use the same technique we used before, and we have to put, look here, here, look at this, where it is, this one. Here we have to do the F silk. So I skip now this process because basically it's the same like we used before with the clearance, and now it's time to give the 3D model. Okay, so let's do this one. We get to this up here is a footprint properties. This is the window that coming up, and now we have to add the 3D model, which I can find in my directory. This is the Kicad directory. I had to go to the my one, and this is the model we are going to add in our footprint. Now it's going to click OK, and now we have to fix it to see. Now is we have to move it in order to match, put the pin in the same holes, and now it's moving in the Y offset, no, that one is 0 0. Now it's moving down, moving back. Here it is, going down, 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 down. I'm gonna move, zoom a bit so we have better clue. Okay, okay, here is 48. There is, you see that there is 2 holes missing. This is not actually important. I mean, in that case, in our case, this one, because this one is I've used the Arduino footprint, which has these 2 pins also. This is not our case, so we have these 2 spare pin void. Not we not there is nothing connected, so it's okay for our purpose. It's okay. Maybe in some other project that is more serious or not, we have to correct that one. But for now, it doesn't harm. Actually, it's something that is can stay there. Okay, so it's 0.3. Now we see back if there is something that is to fit better. You see now it seems quite good now, eh? more or less is okay. Yeah, I like it. Okay, so here we are. Is I think is finished. Okay, and save it. Now we test it with a very small circuit to see if everything is okay and all the 3D is rendered well, and we don't have problem to create a PCB. Okay, now we place our component. Is this one? Okay. Is shade. It's okay. Now we can generate. Now is yeah, we have to first give the name, annotate, yes, close, okay. Then we have to generate a netlist. A netlist, yeah, okay, okay. No, this one, no. We go now to the PCB. Now that we created the footprint, we had to associate with symbol. So we had to recall back the symbol we created before. Is this one is down is on the shields. Here is that one, and now up here edit symbol properties, and we have to choose the footprint we just created. So it's it was up here, was a pinco pallino, that one, and we give it insert footprint in board. Here it is, and now we do okay. So now we can close it and save it. I would like this point to open parentheses upon the pretty directory that Kicad creates when we are creating footprints. What I'm referring to is to this pretty directory here, which is here located in personal folder, personal directory. And if we check what is inside, we see that there are two files with the same name of this library here, and which is the library of the footprint. It's interesting to see what inside these mode files, and I found out that actually there are some instruction how to create the footprint and distances and sides and so forth. Then there are also here the path to the 3D model. So it seems that there is a strong relationship between the footprint and the relative 3D. If we break this relationship, of course, things are not working how we want. So we have to understand that the once we have created a library in for the footprint, also the 3D model must be actually the same path specified in the mode file. Okay, this one I move to place it here. Okay, so now I give the schematic the annotation, close, and generate the netlist. Okay, now I created the PCB, exposed the netlist from the schematic, and I created this PCB, very simple. It's actually this this shield with a connector for the power, and now we can test to see how it is the 3D view. So 3D view. Okay, here we are. We got the PCB, and the connector here is not there is no model here, but we are focusing our interest in our model, in our shield. So it seems that the shield is working perfectly. So that's all, folks. So that one is all the steps to go through to realize a custom footprint and custom symbol, relative footprint, and 3D associated. That's it. So let's see next time. Bye now.